Hello, Math Studies students, and welcome to your online lesson. Today we'll be talking about asymptotes of unknown functions. We've mentioned asymptotes casually in class, and we have a rough idea of what those are, but today we're going to really talk about what they are. We're going to figure out how to find them looking at a function or using our graphing calculator to help us out a little bit. So what is an asymptote? An asymptote is a line that a function gets closer and closer to but never reaches. So it's not actually part of the graph, similar to how if we had a quadratic function and we had an axis of symmetry coming through it, we often will draw that with like a dotted line going right through the vertex. I'm not sure I drew that particularly well, but that dotted line is obviously not part of our parabola. But it's useful because it shows the reflection that we have between the left side of the graph and the right side of the graph. And that's similar to what we're talking about when we talk about an asymptote. The asymptote itself is not actually part of the function, but it's a line that our graph is really getting close to. And so it could be something where we have this dotted line here and our graph is curving towards it. And as we get closer and closer to it, it's going to almost look like it becomes it, but it's never quite there. It's the idea is if you have a wall and you have a ball there, then you cut that distance between the wall and the ball in half. Now we're here, and we cut that distance in half. Now we're here. You can keep cutting that distance in half. You never actually touch the wall. You're just getting closer and closer to it, and that value that you're cutting in half is getting smaller and smaller and smaller. That's really what's going on with an asymptote. So we're getting there, but we never actually reach it. So how do we find asymptotes? For functions that contain a fraction, and we'll look at some examples of what those look like, but if they contain a fraction, a vertical asymptote, and that would be an asymptote similar to an axis of symmetry, a vertical line, it occurs when our denominator equals 0. And why is that? Well, if I have something where I have a number and I'm dividing it by some unknown value, I can take a 5 and I can divide it by 10. That would equal 1/2. I can take a 5 and divide it by 1, that would equal 5. I can take a 5 and divide it by a fraction, like 5 divided by 1/2. Multiply the reciprocal, I get 10. I can divide it by lots of different numbers. I can divide it by negatives. But the one thing I can't divide by is 0, because it's saying take 5 things and put them in 0 groups. No, I can't. I have 5 things. How can I group them into 0 groups? I would have to subtract them to make it 0. And so you can't divide by 0. So anytime we do that, that's a value that we can't put into our function. So we'll look at some examples of that coming up. And then horizontal asymptotes, and those are our lines like the horizon that are going along like this. Those you kind of have to look at the graph and see what's happening, but it'll also show you a shortcut that we can use when we don't actually look at the graph. But we have to think about what's happening as our input approaches infinity, or our input gets very, very, very large. And I don't mean large like 10 or 50 or 100. I mean large like billions and trillions and approaching Google, which is the one with 100 zeros after it. Really large numbers. What would our function be getting very close to? And that's going to help us find our horizontal asymptotes. One other thing to point out is how do we write the equation of a line? Well, normally we would write the equation of a line using our y equals mx plus b form. However, if we have a horizontal line, one of these values becomes trivial because our slope of a horizontal line becomes 0. And so these will all cancel out because 0 times anything goes away. And so you literally just have y equals some number, which would be our y-intercept. So you could have a horizontal line like y equals 5, which would go through 5 on the y-axis, but it's just a nice, flat, straight, horizontal line. And then the other kind of line, and we've talked about this before, is a vertical line. And that's the same deal. So we just write x equals. It can't be written as y equals mx plus b because it has an undefined slope. So you'll see lines like x equals -2 or x equals 15 or something like that. And those would be our vertical lines. And the asymptotes that we're talking about today are either going to be horizontal lines, so y equals a constant, or a vertical line, which will be x equals a constant. So here we have a function, g of x is equal to 3 plus 2 divided by x minus 1. And this is similar to what we talked about in the last slide, where there's a fraction in our function. And what can we not have in our denominator of a fraction? Well, we can't have 0. So I know that my graph cannot have 0 in this denominator because 2 divided by 0 would be undefined, and so I can't put in a value that would make this 0. Well, it's not a matter of x not being 0 because I could actually plug in 0 for x, and I would have g of 0 is equal to 3 plus 2 divided by 0 minus 1. Again, I'm putting in a 0 for that x. Well, 0 minus 1 is just negative 1. So I'd have 3 plus 2 divided by negative 1. 2 divided by negative 1 is negative 2. So I would have 3 minus 2. And so I know that g of 0, or when my input is 0, I output a 1. Because 3 minus 2 is 1. So that's not a problem. It's not that I can't plug in a 0. It's just that I can't let my denominator equal 0. So you'll notice here on the left, I took my denominator, the stuff that's in the bottom of my fraction, and I have x minus 1 in the bottom of my fraction. Well, I don't want it to equal 0. So why did I set it equal to 0? Because I have to find out what I need to avoid. Where will my asymptote be? And we can just do simple railroad tracks here, where I add 1 to both sides, and I get x equals 1. As I mentioned, this is for vertical asymptotes. And I also mentioned that vertical asymptotes we write x equals. And so I have a vertical asymptote when x equals 1. Now, horizontal asymptotes. For a horizontal asymptote, I need to think about what happens as x gets very, very, very large. Well, what if I made x not be that large, but I made it like 3 plus 2, and let's say my input was 10. Kind of big, but not that big. And in the grand scheme of things, really not big. But so I take 10 minus 1, and I'd end up with 3 plus 2 over 9, so 3 and 2/9 if I leave that as a mixed number. Okay, let's make it bigger. Let's make it g of 100. So now I've got 100 minus 1. How is that going to affect things? Well, this is now going to be 2 over 99. Now, 2 over 99 is pretty insignificant. You know, like there's, 100 pennies in a dollar, and so 99 is just one less than that. So this is like 2 cents is what we're talking about here, 3 and 2/99. Okay, well, what if we made our input even bigger still? What if we made it something like g of a billion, 0, I can't even fill all those in. We'll just make it a million then, so I can fill all those in. So now I've got 2 over a million here. So, again, minus 1 was my original function. So what do I end up with? 999 and 2 over there. Well, what is 2 divided by that? Or think of it this way. If I had almost a million marbles here, and then somebody compared and they said, I have 2. I mean, that's insignificant. It's hardly anything. And what's happening and I can pull up a calculator and show you this, but as we start dividing by larger and larger and larger numbers, our value is getting smaller and smaller and smaller and smaller. And what value are we getting really, really close to? Well, as this number here in the bottom, and again, a million is not that big. I can keep adding zeros all day long and make this so much bigger. But what's happening is our number's getting smaller and smaller and smaller, and we're eventually approaching 0. So as our x value gets really large, as our x value approaches infinity, this value of 2 divided by, x minus 1 is becoming really, really small. How small? Not negative small, but small like nothing. Like there's nothing there. And so what this really ends up happening is canceling out as x gets larger and larger. So we end up with a value of just 3. And so our horizontal asymptote would be y equals 3. And so that was me finding my 2 asymptotes without using the calculator at all. Now let's get out the calculator and see if we can find those asymptotes using the calculator. So the first thing I need to do is go to my y equals on my calculator. So again, I just hit my y equals key, just cleared everything out. Now I'm going to type this function in. So I have 3 plus 2 divided by, and now there's a group in my denominator, x minus 1. So it's very important that I have a parenthesis here, x minus 1, close my parenthesis. And now I'm going to graph this. It's a little hard to see what's going on here. I'm going to zoom 6 to get sort of standard fit. So I'm going to attempt to trace this with one of my pens here. And so we've got this graph that's coming along, and then it's curving down, and then it makes a jump, and it comes up. And you can actually see here on the calculator is literally kind of drawing the asymptote right here, which I just sort of traced in green. And it's not doing that as a feature, it's kind of just doing that as the calculator is trying to connect all the values, and so it's just jumped from there to there. Honestly, it's not that easy to really see what's going on here, but what I'm going to do is I am going to just go to my trace key, not my zoom trace, but just my regular trace. And as I go from left to right now you can see that my x value is around 4.5, my y value is around 3.5. As I continue to the right, it's going down. It's going down to 3.27 now. Again, I'm looking at this y value right here. Just covered it up, but it's 3.27, and as I continue on to the right, it's going down. It's going down to 3.19, 3.16, 3.14, 3.1. And if you look now at this graph, it almost looks like we have just a nice straight line happening here, where it's totally flattened out. And yet, as I trace over, I can see it's not flat, because now I'm down to 3.09, 3.08, so on and so forth. What number am I getting closer and closer to? Well, I'm getting very close to this number 3. So my graph is approaching a horizontal, a vertical value of 3. So my asymptote is basically this horizontal line here. Sorry, my grid is off a little bit, but of here where y equals 3. Now, if I backtrack a little bit, let me do zoom fit again so I get the standard window. You can see that right around where x equals 1, I have this sort of vertical jump happening. And we already confirmed that asymptote because we tried plugging in or figuring out what value would make our denominator equal 0. So those are the two ways that we found our asymptotes. Again, you can use the trace function and sort of see what happens to your calculator. Let me show you one more thing we can do. We can change our window. And right now I've got my x max 10. But what if I change it from 10 and make it something more like 1,000? And so then as I go back to tracing this, and I move over, you can see that my y value is now getting very, very close to exactly 3. And this is with an x value of around 700 here. I'm really close to 3, and I can continue on, and I'm going to get even closer to 3 as I get closer and closer to infinity. All right, let's try one more of these, and see if we can find another vertical and horizontal asymptote. So starting off with our vertical asymptote, in order to have a vertical asymptote, that's where our denominator would equal 0, because that would mean we can't have an x value there. And so I'm just going to take my denominator of x plus 2, set it equal to 0, subtract 2 from both sides, 2 railroad tracks, x equals -2. So that is the equation of my line of my vertical asymptote. Now, what about my horizontal asymptote? Well, again, for the horizontal asymptote, we want to make x really, 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 really big. And if I look at this fraction, 1 over
Serenity
x
Lockhart.
plus 2,
Please report to the
and I make
school
that
office.
x a little bit big,
Lockhart
like I put
to the
in
school
a
office.
10, I would have 1/12. Okay, so that's a value of 1/12. But if I get even bigger, like let's say I put in 100, now I'm going to have 1 over 102. Suddenly that's becoming like less than a penny. As I make x even larger, make it something like 1 over 1,000,000 plus 2, which would be 100, or 1,000,002, the 1 becomes insignificant. I'm down to essentially nothing. 1 out of 1,000,000 is hardly anything at all. And that's what's happening. As x gets larger and larger, our value of 1 over x plus 2 is essentially becoming nothing. And so we can cancel that out as x gets larger and larger. And what's left? We have y equals 4. So our horizontal asymptote is y equals 4. All right, now let's confirm that on the graph. So right away I went to my y equals, I plugged in my function, making sure to put my denominator in parentheses. So I have 1 divided by the quantity x plus 2, and then plus 4 after that. And with our graph, we can see, let me do a zoom fit again here. Again, we can sort of see that, I'm going to call it noise on the calculator, where it's really kind of showing where that vertical asymptote is. And just looking at the scale, it looks like it's right around x equaling -2, a vertical line when x is -2. And then we have a horizontal line happening right here, roughly. That is right around y equals 4. Again, we can go back to our window and really extend it out and make sure that our graph is going there. So I'll go to my window, pick a large x value of, I did 1,000 last time, so we'll do that again. Go back to my graph, just do a trace, start following this along, and we can see as we're going further and further along, right now we have an x value of 495, and our y is so close to 4. Is it right at 4? No, it's just, a little bit away, but if I was rounding this to 3 significant figures, it'd be exactly on 4. So that is finding asymptotes. Again, for vertical, we set our denominator equal to 0. For horizontal, we see what happens as our x value gets really, really large. All right, till next time.